We are now in formula number 9 of evaluating Laplace transform problems, where the formula written as the Laplace of the product of the function t multiplied by cosine omega t equal s square minus omega square divided by the quantity of s square plus omega square raised to square. Now let us try some problems to illustrate the application of formula number 9. Say the given problem is the Laplace of the product of 7t multiplied by cosine 2t. This Laplace problem can now be written also as 7 multiplied by the Laplace of the quantity of t cosine 2t. Since 7 is a multiplier, we're going to place 7 before the Laplace symbol. So we have the 7 here. And if you take a look at this function, t cosine 2t takes the form of formula number 9, t cosine omega t, and this is t cosine omega t. Then therefore omega is equal to 2. Since we know the omega 2, we are now ready to substitute omega equal to 2 in this formula. So we have s square, just simply copy s square, minus, copy the minus sign, and omega happens to be 2, and that is being squared, so square 2 divided by s square plus omega again is 2, and then square it, and then square the denominator, so that is being squared, and simplifying it now, so we have s square minus, and then 2 square is simply 4 divided by the quantity of s square plus 4 raised to square. This expression can now be multiplied by 7 since this is a multiplier, so we will multiply this by 7, and what will happen then, this becomes what? So we have 7 multiplied by s square minus 4 divided by the quantity of s square plus 4 raised to square. And the final answer now can also be written as f of s equal to 7 multiplied by s square minus 4 divided by the quantity of s square plus 4 raised to square. For problem number 2, we have the Laplace of the product of 4t cosine of 6t. Again, this function or this Laplace transform problem can be written down as 4 multiplied by the Laplace of t cosine 6t. 4 is a multiplier, so we're going to place that before the Laplace symbol. And t cosine 6t takes the form of formula number 9, which is t cosine of omega t, happens to be the same as t cosine of 6t. Then therefore omega is equal to 6. Since we now have omega is equal to 6, we are now ready to substitute the omega is equal to 6 here in this formula. So we have s square, so just simply copy s square here, and then the minus sign, and omega is equal to 6, so we need to square 6 here, divided by s square, copy the plus sign, and omega is 6, and raise is to square, and then raise to that quantity square. So we have s square, simplifying it, so we have negative, so we have negative 36 divided by s square plus 6 by 6, so we have 36, and that is being raised to square. Since there is 4 here, we will multiply this by 4, so the final answer now becomes 4 multiplied by s square minus 36 divided by the quantity of s square plus 36 raised to square, and that would be the final answer. And it is also written now as f of s equal to 4 multiplied by s square minus 36 divided by the quantity of s square plus 36 raised to square. Now let us try the last 3 problems. So we have problem number 3, we have problem number 4 here, and the last problem number 5. Now if you observe 8, 7, 1, and negative 4, 5, 2, 5 are constants, we can simply shorten the solution by just simply write the final answer directly without writing the solution by applying formula number 9. So we have this formula. So we have s square minus omega is simply 7, so square 7, so we have 7 square, that is 49, divided by s square, plus omega is 7, so we have plus 49, and then that is being raised to square, so square 8, and multiply it by 8. So we have 8 s square minus 49, and that would be the final answer for number 3. And for problem number 4, so we have s square again, just simply copy s square, and then the minus sign, and omega is simply 1. Okay, since there is no coefficient here, it is understood that the coefficient is 1, so then therefore square 1, so that is 1, divided by, copy s square, the plus sign is also to be copied, and omega is simply 1, square 1, so that is simply 1 also, and then copy square here, and then multiply that by 1 also, or negative 4, so that becomes negative 4. The final answer is negative 4 multiplied by s square minus 1 raised to square. And problem number 5, we have s square minus omega is simply 5, square it, so we have 5 square, so that is 25, divided by s square plus omega is simply 5 times 5, so we have 25, and that is being square. And since there is 2 here, which is the coefficient of t, and there's also 5 here, which is the coefficient of the Laplace symbol, we will multiply 2 by 5, and that becomes 10. So the final answer, there is 10 here, so multiply it by 10, and that would be the final answer for problem number 5.